Hello, and welcome to today's webinar, Introducing the Digital Capabilities Model for Supply Networks. I'm John Stoltz, Director of Customer Experience for the Association for Supply Chain Management, and it is my pleasure to serve as the host for today's event. As we know, digital capabilities are disrupting the traditional supply chain operations reference, or SCOR model, and driving more complex and tightly integrated supply networks. In response to this rapidly evolving landscape, Deloitte Consulting and ASCM released version 1 of the Digital Capabilities Model for Supply Networks, the DCM. This new model will help businesses develop capabilities to increase efficiency, drive results, and innovatively enhance performance. In today's webinar, we'll learn more about digital supply networks, including the capabilities and their interdependencies that transcend physical and digital boundaries and include people, processes, and technologies needed to break through traditional organizational silos and be competitive in the digital age. Please note that this webinar will be recorded and posted on the ASCM website following this broadcast. Now it's my pleasure to introduce our presenter for today. Chris Richard is a principal in the Supply Chain and Network Operations practice at Deloitte Consulting LLP, focused on supply chain strategy and product development, and has over 25 years of professional experience in consulting and industry leadership in the semiconductor and high-tech industries. Prior to Deloitte, Chris served in leadership, operations, and engineering roles in the semiconductor industry and the military. This included senior engineering and leadership roles at Intel Corporation, where he worked for 10 years after starting his career as an Army Ranger. Please join me in welcoming Chris.
Well, thanks, John. I'm glad to be here today and taking the opportunity to go through the overview of the DCM model. This is the same presentation we made at conference where we launched it, and this is a great opportunity. Appreciate it today to be able to get this out to a much wider audience. So today we're going to cover really four things on the agenda here. We're going to start by talking a little bit around why digital supply networks, kind of following on what you just introduced, John. Then we're going to talk about the journey that we're headed on, right? And we're really at the start of a journey here to develop these capabilities. We're then going to go into an overview of what we've released in this first version of the DCM model, and then we're going to close by talking about what's next. So that's what we'll cover today. These four areas. So a year ago we introduced the concept that digital supply networks were coming, and what we talked about is how do we start shifting our thinking from the kind of traditional way of thinking about supply chains to what the future is going to bring. And so here you see a representation of basically the SCOR model, right? So in here you can see plan, source, make, deliver. And a lot of companies, as they've used the SCOR model over the years, have added other connections, if you will. So for example, to product development and customer support. But this is how we've been looking at supply chains for a long time. Now one behavior characteristics of almost every supply chain is the bullwhip effect, and supply chain professionals deal with this all the time. And what really lies behind here is the delay in passing of information, the delay in physical transport of physical goods, and it has the net effect of amplifying errors and in the signal as you go back upstream, right? So it's the classic situation where you have a little bit of demand volatility maybe out at a retailer, but by the time that gets back to the manufacturer or the capital equipment company that's making machines for the factory that makes the device that eventually gets bought through that retailer, the perturbations in the supply chain can be quite large. And so we've been asking ourselves at Deloitte for years, is there a better way through this, right? Do we have to accept the bullwhip effect and the other challenges in supply chain operations as is, or can we do something very different? So as we started to think about this, we we really started to think, well, how do we move from supply chains, which are more of a linear construct, to supply networks, right? Where the different nodes of the network here kind of still play the same, largely the same functions, but do it in a very different way, do it in a very coordinated way that allows us to remove those latencies, those delays in information transmission, and and really get after the bullwhip effect that we were just talking about. So for us, this is quite a paradigm shift. And going from the traditional model where we first plan, then we source, then we make, and then we deliver, but moving on to a different paradigm where we start thinking about how a network operates. And when you look at a network and you look at control theory behind a network, what a network is doing is first sensing what's going on. So what's sensing the demand, sensing the supplier capacity, sensing the status of operations are all examples of sensing. But once we sense, a second key attribute about operating in a true network is collaboration, right? How do we effectively collaborate across all those different functions to really come up with an optimal solution to the problem at hand? And that's what we mean by the third point, optimize. And then based off that most optimal way to address the situation, we then respond. So that's the paradigm shift that really has driven our thinking is how do we operate in this kind of circular cycle here where we go through these four steps of sense, collaborate, optimize, and respond. So to illustrate this, we want to show a video we put together that brings this to life, and it's a little bit of a dramatic video, but I think when you look at it and you think about it, you can really see the art of the possible here. So let me start the video here, and it will play for a few minutes here.
Command, I'm getting an alert. It appears we have insufficient inventory to fulfill an incoming order.
Production, what's going on?
We're predicting schedule changes due to unplanned weather conditions.
Analytics?
Forecasts show a storm hitting in 24 hours. Social listening confirms the track, and sensitivity models are predicting asset downtime due to flooding and workforce limitations.
Delays in delivery of raw materials could cause capacity loss of up to 26%.
Production, what can we do?
Running alternative production scenarios now. Our best option is to add capacity at the Northeast plant. An overtime shift would meet demand at positive margin impact. The problem is raw material inventory is too low for additional production.
Supply, if we did go into overtime, is there anything you can do to get the raw materials there in time?
Scanning inventory positions in storage and in transit. I've got raw materials on their way, but 5 days out. Wait. There's material in a warehouse we could get there in 2 days if we ship by air.
We've got clear weather on that route and a 150-knot tailwind, which will save on fuel.
We got raw materials in 2 days. We could make the order on time and stay within margin thresholds.
Exceptions. Can we make this call to go into overtime and divert materials?
Verifying this is within our tolerance to make a decision automatically. Command, we're good to go. No need to escalate to the supply chain planner.
Okay, Digital Supply Network. Let's do it.
So I hope you enjoyed that video. That really brings to light in my mind the power of a digital supply network. You click the button there at the desk as you're trying to fill an order, and it's happening behind the scenes. It's happening in a way that's quite invisible. But there's I think we see the elements of the sense, collaborate, optimize, and respond, all on that video, right? They sensed where materials were, they sensed an order was needed, they sensed all kinds of things about the environment and the problems. There, was the collaboration, demonstrated as different options were explored. They came up with the most optimal answer they could come up with, and then they responded by confirming the order. So again, a little dramatic, but I think it actually does a really nice job of showing the art of the possible here. So that's the journey we're headed down, right? And we're excited to be here to talk about it today. And as John had mentioned, what we're calling this is DCM, so the Digital Capabilities Model for Supply Networks. And what this is it's a model for the entire ASCM member community to use in charting the journeys, the roadmaps down towards a digital future. So in summary, just want to kind of give you an overview of the model and what we're trying to do here. So what's our objective? So our objective is to provide this profession of supply chain management a reference model to guide the development of digital supply networks. There's just lots and lots of discussion and curiosity and exploration happening out there, but in a very, very unstructured way. This is a model that helps provide structure and organization behind what are the capabilities I should build, and and assisting in determining in what sequence should I build those. So the scope of what we're covering here is what we're calling core supply networks, and so it starts with product development, addresses the functions of planning and sourcing and fulfillment and manufacturing and operations, and then adds on the connected customer, right? And so integrating I'll call it the front end of product development with the other end of connected customer is a really important way to think about these networks, because if you're not thinking about how you serve the customer, you don't really design the network correctly. And correspondingly on the other side, as you're developing a new product, you really want to be doing that in the mindset of, well, how do I optimally deliver that product out to the customers. So that's one part of the scope. The other part of scope that we wanted to call out here is one of our principles here in thinking about digital supply networks is they don't live in isolation of the rest of the enterprise, right? So one of the things we wanted to address here that wasn't native to the SCOR model is more explicit connections between the supply chain organization with its key counterparts, for example, finance and sales and marketing. So that's another aspect of scope. So we're not developing a model for finance or sales or marketing, but what we're doing here is showing the connection points and the key interdependencies with those functions. And then in terms of progression, in 2019, this was our first release. We'll be doing annual releases at conference through 2022. There will be incremental, releases along the way. And in fact, this is December. We launched a few months ago, and we've already made a couple enhancements to the website, right? In the last couple months here. So that's the overview on a page. And if we go into a little bit more here, I was alluding to this on the previous page, but there's really three guiding principles we use to shape how we're tackling this. So they're whole systems thinking, enterprise optimization, and digitally enabled. So by whole systems, it's that collaboration and that optimization that we were talking about earlier. How do we break down barriers? How do we get functions to integrate much more seamlessly and effectively with each other to collaborate and to deliver the best possible result for the enterprise. The second one is enterprise optimization. So like I was talking about on the overview, how do we kind of get out of a siloed way of thinking and think about the whole enterprise? So a great example of that is the product cost, right? That's a really important part of manufacturing. and it's managed in very close collaboration with finance in most organizations. And then, of course, at risk of stating the obvious, is digital supply networks are digitally enabled, right? So we're looking at what are those digital technologies that allow us to really bust the past paradigm, right? Really break those problems that generate the bullwhip effect and other supply chain inefficiencies. So these guiding principles have shaped all of our thinking and all of our design of the model here. So let me show one other video here that provides an overview of the model here. And I'll talk a little bit as it's going. So this is the splash screen of the model. You click on it, you'll have a little video showing the network, and then coming in here, this is what you can see on the web page, right? And we have our 6 level 1 capabilities, and you're seeing what we call the level 2 capabilities explode out from there as you click on each of the nodes. And here's the last one, which is digital development. And now under each of these, you can go and at this point you're prompted to log in. I'm using my Deloitte email, but you would use your ASCM credentials. And when you get into the model here, you'll be able to see the information that lives below the surface there that everyone has access to. So under each of these, we talk about the definition, the vision of kind of what's possible, where this is headed. We talk about the level 2 capabilities in a journey map, right? How do the level 2s relate to the function that they're supporting? And then under each of these, we have 1 or 2 personas where we try to bring this to life in the form of how does this affect a day in the life of a person, right? So up here, we're able to click on before, what was that person's life like? But after you've implemented the capability, what does it now look like? So under each of our level 1s, this is what we have laid out. And then if you click on the level 2s here, it really shows the network, right? So there are 39 level 2 capabilities here, and we've mapped out the connections, between each of them. That's a lot of connections. It's just under 1,500 connections. But to us, this is one of the most important parts of operating a digital supply network, is to see the network of capabilities that enable that. So here, for example, under intelligent product tracking, you see how it connects to probably about a dozen or so additional level 2 capabilities. And then under each of these, you can also click on Learn More and drill down to additional details about each of the level 2s. So that's a quick overview. Again, as an ASCM member, you can log in with your credentials. You can utilize the model. And as I mentioned earlier, we've actually already made some enhancements, beyond what you see here. And an example of those is, for the level 1 capabilities and level 2 capabilities where they relate to the SCOR model, we've added to the website already a mapping of the level 2 capabilities to SCOR level 3 process elements. So with that, let's move forward in the presentation and talk a little bit more about how do SCOR and DCM compare and contrast. And I've introduced little bits and pieces of this as we've proceeded in the webinar so far. But this kind of sums up those points. So what's the paradigm of SCOR? It's a supply chain, a kind of linear operation in contrast with the supply network. The organizing structure. So SCOR is very hierarchical. You start at level 1, you go to level 2, you go to level 3. The organizing structure, as you saw in the video just before this, are relational. How do the capabilities relate to each other through the concept of digital threads? I mentioned the cross-reference. So for each of those level 2 DCM capabilities, that relate to SCOR, the SCOR model. We've made that mapping. And in terms of model orientation, SCOR really is there to talk about, well, what are our processes, and how do we define those, how do we improve them. The orientation of the DCM model is capability, right? What capabilities do I need to fit with my business challenges, and what is the maturity of that capability? And then the final thing I'll mention here is the bottom row here on technology relationship. In SCOR, the paradigm was, well, let's figure out our practices and processes, and then we'll figure out how a technology can implement those. In DCM, we're looking at it differently. Again, our third guiding principle on digitally enabled applies here, where we say, well, what are these technologies that can transform our practices, right? So how do we adopt capability that just simply didn't exist in the past? So that's a quick overview of the compare and contrast between the SCOR and the DCM model. On that overview, I talked about the concept of a digital thread. And we actually have one more video to show here on the digital thread. But an example here is that we'll be showing is about the optimization of a part that goes on an aircraft called a bell crank. And there are 4 steps in this digital thread. The first that we'll see is how do you scan, analyze, and design this part. And that relates to our model-based definition capability in the DCM model. And then we go on to look at, okay, well, how do you build and monitor that through an accelerated proof of concept? At that point, it moves into manufacturing with a digital process twin. And then finally, the product is ready to ship and go to the field and be able to be monitored while it's in use. So with that, let's show the final video here that shows a digital thread in action.
Welcome to One Aviation, a maker of very light jets. In the highly competitive world of aviation, it's not enough to just make an innovative product. You have to make that product better, faster, and more efficiently than your competitors. That means leaving nothing to chance. Long before the pre-flight checklists and physical evaluations, before test flights and production runs, One Aviation had already run this plane through its paces. That's because it's been designed and tested in what's being called the digital thread. Luckily, a few One Aviation team members agreed to meet me here early this morning to talk about it.
Hey guys. Good morning.
Morning. What's going on?
Well, today we're preparing to go fly.
That's Ryan Jennings, Director of Structural Systems Engineering here at One Aviation. He'll be my guide on how the digital thread weaves its way through this operation.
You guys aren't freaked out about this?
Not a bit.
No, we're excited.
Not one bit.
How do you know? How do you know that this is going to work?
Almost every piece on this airplane has a digital representation, or maybe what you would refer to as a digital twin.
Yeah.
But we know pretty much everything about this plane. There's nothing we don't know about it at this point.
So you've tested this plane in the virtual world before you ever fly it in the real world.
It's not just the physical pieces that you see that are coming together as an assembly. It's a simulation along the digital thread of also the manufacturing process, the inspection process, the qualification process, all that stuff. There's a theme here that goes along with, we want to know what happens before it really happens in the real world.
Okay, so what is the digital thread? And can it really help One Aviation thrive in the competitive category of very light jets? To help define it, we've assembled this visualization. The digital thread is a single, seamless strand of data and computing power that stretches all the way from cradle to grave for a product. It gives you the ability not just to monitor something in a linear fashion, but to take learnings along the way and feed them back into the next generation of whatever object we're making. It could change everything.
What we like to do is just jump into a simple graphic of how to visualize this. So this is our standard digital thread graphic across 4 distinct phases to help internalize what this looks like. So we have scan, design, and analyze, build and monitor, test and validate, and deliver and manage.
Okay.
And so scan, design, and analyze are some of those upfront steps that you saw during your journey.
Yeah, so we started with, we got a bell crank, right?
Mhm.
We've all seen this before. So we started with a part that looks a lot like this that exists on an airplane today, and then we ended up with this topology optimized part. That's all.
Exactly. Yep, so that's the upfront. There's some design work there, but also the computer-aided engineering work to look at, what are our inputs into that topology optimization to look at how we improve the design the next iteration.
Okay.
So both the design and the analysis step. And coming out of that first phase, what we have is really a as-designed model of our part that we're going to produce.
Okay, so I know what I want.
You know what you want.
That's the design.
You have the specifications of how you're going to get there. That's the as-designed model. And the idea is that you package those outputs in a usable way and send it off to a machine operator to actually manufacture a physical part.
Okay.
So to go from digital to physical.
Okay, and this is where all the in situ monitoring that we did,
Exactly.
Watching the thing be built, that's all in this notion
Capturing
of
post-processing activities, all that information is gathered here, and then all of that data is packaged into what we consider to be an as-manufactured model of the part.
Okay, so I have as designed and as manufactured.
Exactly.
Okay.
And so those two pieces...
So I know what I wanted and I know what I got.
Exactly.
Right? Okay.
The whole idea there is that in the test and validate step, a testing technician wants to compare that as-manufactured model against our as-designed model to see whether or not we can field the part. Does it meet its performance requirement?
Okay.
Yep. And then not just that, but once you actually field the part, how can you continue to learn from your part as it's out in the field? So via performance data that's collected, usage data that's collected, how can we understand those performance conditions that the part's being subjected to and help it inform an even better design in the future? And so we call that an as-maintained model of the part.
Oh, okay.
So you actually keep a live digital representation of that physical part in that landing gear assembly as our example.
Okay, so I got as designed, I got as manufactured, and I got as maintained.
Yep.
Okay.
Throughout the process, in each of those individual steps, like we talked about in terms of simulations and the machine instructions, you're collecting, these icons show just the body of knowledge that's flowing through the process. And so at every single phase, there's more knowledge that's being collected.
Got them all the way, going all the way.
and they're all the way down.
Yeah. Feedback.
Yep, and in the feedback part, there's many different feedback mechanisms throughout, but the most notable one that I think has a lot of value to it is capturing this performance and usage data over here on the far right and getting that all the way back into design. So we can understand the actual loads that bell crank is experiencing in the landing gear assembly.
Yep.
We know if it's greater or less than what we expected it to be. And we can improve upon our simulations to keep producing better and better parts as we gather more and more data. And that's one of the big benefits of that feedback loop.
So, so that's actually a splice or merge of a few different videos that are out there. If you search on following the digital thread, Deloitte, you'll find them. They're on our YouTube channel and a few other places. And if that was interesting, that's actually a very small subset of a 9-part video series that goes into a lot more depth on those areas. But wanted to show that to show, well, what do we mean by a digital thread? Because what we really see is that when you think about the digital threads, that's when you start to think, really think about how do I optimize my network, right? If you think about it in too much of a compartmentalized way, too much of a decomposed way, then you don't achieve the power of the network. So look at the videos, play around with the model, and should start to kind of open your eyes and open your ways of thinking about how these capabilities connect with each other. So we're at release 1 that we released in October, and what's coming next? As I mentioned much earlier, we've got up through release 4 planned. We're incorporating feedback all along as we go. We're starting to kind of lock down exactly what we're going to be doing over the coming year. There's certainly been a lot of requests from the SCOR user community to understand how do the two models relate. So we've already done some work around that you can find on the website. Definitely we'll be looking at what are the appropriate metrics to measure maturity and performance of the various capabilities. As we do that, we'll be keeping that very closely aligned where appropriate with the metrics in the SCOR model. Obviously there are types of metrics around a digital capabilities model that are digitally focused and SCOR doesn't address, but we'll be keeping them closely aligned there. There's been a number of discussions around should we do industry-specific versions of the model. We'll be considering that over the coming year, but there's a bunch more to come. And back on the website, we've got a feedback button there in the upper right-hand corner where you can click and you can send feedback in around what you would like to see. So I've been talking about a few of these things, but if you look at our product development, for example, there's a lot of other things we could have included in there: design for quality, design for supply chain, design for cost. We're looking at some things like that. The marketing integration, right? There's marketing can have a big impact on the supply chain when it changes a price or runs a promotion. Looking at more real-time collaboration tools, which aren't, really explicitly addressed in the model. So there's a lot of different things that we have the potential to incorporate as we go forward. This is a kind of a teaser list, and again, the ASCM community is providing feedback, and we welcome that feedback as we continue to evolve it. So that's what we had for today, John. We are at the start of a journey here. We're really excited about it. We're excited to be working with ASCM, and that's what I had for today, John.
Perfect. Thank you, Chris. Really great information and a lot of it. A lot to digest, but clearly it's a very different way of thinking about supply networks, this evolutionary supply chain, and how it all comes together. And I absolutely appreciated, kind of the roadmap over the next, year or so in terms of what the community can expect as we look ahead to the annual conference in 2020, which will be, again, continuing to share more details, more insights, hopefully case studies around the DCM model and how it's been deployed. Let me close, Chris, just with maybe a broader question. Thinking that if an organization is not currently pursuing digital transformation, but as an individual working, in supply chain, I've got a curiosity around all things digital. What's the relevance of the DCM model to me, and how can I leverage the work that's gone into this to kind of as my continuing professional development, if you will?
Yeah, great question, John, and that as part of the answer, I should add in here that when another one of our kind of guiding principles as we went through this was we didn't want to publish a book, right? We didn't want to publish a long, lengthy document that you have to read in a linear fashion. We wanted to, provide the information for, the audience that you were just inquiring about in this very interactive, exploratory way. So my response to that is, have the practitioner log into the model and start playing around with it, right? So you can start with what you're familiar with. So for example, if your professional career has been in the planning area, then start with synchronized planning and start clicking onto those level 2s and really exploring what they are. And I think what the practitioners will quickly find is they'll see some capabilities that look familiar, and they're similar to what they've been doing. but for their careers, but maybe have more of a digital feel. But then they'll have other capabilities that are kind of out there on the edge, and they're really pioneering. But we've designed the whole website to be a great learning vehicle to click around on and figure out how it relates to the job you've got to do every day, and hopefully through the visualization, what people will have a much better appreciation for is that capability that they're using in their day in and day out job. How does that relate to the rest of the enterprise and the rest of the organization? So we're really expecting that people will have their apertures expanded right as they think about the interdependencies within the organization.
Great. Thank you, Chris. That's all the time we have for today. On behalf of ASCM, we'd like to thank Chris for his time, as well as our attendees for participating in this ASCM webcast. ASCM and Deloitte are continuing to develop the DCM model, and we look forward to sharing more insights in future events and webinars. As a reminder, today's presentation will be available on the ASCM website following this broadcast. All content and material included in this edition of the ASCM webcast is the property of ASCM and is protected by the United States and international copyright laws. All rights are reserved.